Alright, let's do some more physical computing stuff today. We're going to learn how to use Arduinos, if you've heard of those. They're very exciting. So, yeah, let's get right on into it. First things first, let me give you a link to my Tinkercad profile if you ever want to use any of the stuff that I did in class from before and some stuff that I'll show you today. Like here's the stuff from before, and here's some things that I will be showing you. I've just got a bunch of pre-made examples for the day. The first one is this one. So this is what an Arduino looks like, by the way. If you haven't heard of one before, it's just a nice little device that you can like plug in wires to and look at cool things, and like you can program it. You can program it and it can like turn on lights among other things. All right, so let's talk about this. So the Arduino is just like a tiny little device with the CPU on it, and I forget what kind, honestly. It could be an ARM CPU for all we know, but you have to program it in like the Arduino language, which is an interesting one. Alright, so yeah, let me give you a blinking lights demo of the Arduino. So here's this. And to build it yourself, like in the basic components, legitimately you can drag out an Arduino and you can hook it into things. It's being powered by this little virtual USB slot here. So you can drag power out from the Arduino. There's 5 volts of power, 3.3 volts of power. There's analog little pins here, and then there's digital pins here. And we're gonna focus on the digital ones. Okay, so let me delete that one. Okay, so back to just this one. So here is an Arduino, and I've done stuff with it. All right, so first of all, yeah, digital GPIO pins are what we're gonna be talking about, and they are a way for you to programmatically supply 5 volts, okay? So there is a way to just say, hey, Arduino, I'm hooking into pin 3. I'd like to, in my program, I'd like you to turn pin 3 on and off, like make it 5 volts, make it 0 volts. So that's what we can do. We can make it high and low, all right? So that's eventually what's going to happen. Let me actually, before I even draw that for you, let me just like have this work for a second. You can drag into power if you'd like to. So here's 5 volts in ground, so positive and negative. I put that into my breadboard up here, and you could just use that to power an LED. And apparently for an LED you need like a 200 ohm resistor when it's 5 volts. So that's fine. You can just hook into it just like a battery. That's one thing we can do. But then I also want to show you this program that's going to like blink the light on and off pretty fast. Okay, that's going to be the goal. All right. So you can see the simulation time is not really real life time right now. It's going slow because it's like simulating electrons moving, but it's not too bad either. All right, oh, there it goes. It kind of caught up. Nice. Just had to warm up maybe. So you can use it in Arduino just like a battery if you'd like. This is like a Tinkercad comment. So that was us doing that there. But we can also hook into one of these pins. These GPIO pins stands for General Purpose Input Output pins, the digital ones at least. And we can write a program inside of our Arduino, like shove it onto here, and have it supply power on and off, 5 volts on and off, make it go high and low, and power some other things. All right, so that's the goal. So that's what we're about to do. I've made a program that says, hey, pin number 3, so you can programmatically change these pins. It'll like oscillate between low power and high power, low voltage and high voltage, lowercase low and capital high. Okay, so that's kind of what we're doing. It's like almost practically 0 volts, all the way to bringing it up to 5 volts, like, and just oscillating that every second or so. So almost 0 volts and then like 5 volts. All right. So that is the first example. Let me show it to you. So it's a little program in the Arduino. If you go to, there's a code tab here now that we have an Arduino involved, and so we can program this particular Arduino in a couple of different ways. So yeah, this is a code blocks way, like this is if you've used Scratch before. This is that. There's also actual code somewhere. If we go to the blocks version, blocks plus text, select the corresponding actual Arduino language, and then there's also just the text version. So can I zoom in at all here? Oh yeah, cool. Large font for us. Nice, nice, nice. So yeah, this is the program that's running on the Arduino right now in the code section. You can program it using these cute little blocks, or you can actually write it down here. But this is the real code, and it's being automatically generated from here. And Arduino programs, they run by default in a loop. So what I'm doing here is I'm saying, like, drag this out. These are all just lines of code essentially running in order. Set pin 3 to high, All right, so it's turning on, like when I start the simulation. Set pin 3 to high, which is going to power the LED, and wait a second, so keep it high for a second essentially. Set pin 3 to low, which means like turn off the power to pin 3. So that's going to turn the LED dim, and also wait a second. And that's just going to keep repeating those 4 lines, okay? That's kind of how that works. And so, yeah, you can add a little code for yourself here. Here is the loop that's being written for us. I don't know if this is a necessary thing, but like you could add your own variables, and they can be set on or off. But this is somehow, I don't know why this one's here, but honestly, it's being automatically set by this stuff, even though that variable is unused. But yeah, there's like 2 functions that you're writing. This is the Arduino language. It's kind of like C++. But like this gets run when you turn it on. The setup thing is like pin 3. This thing, pin 3, is going to be used for output. That's what we're saying here. And then in a loop, like this keeps getting run a million times, over and over and over until you like turn off the power to the Arduino. It's like digital rate pin 3 high. So tell pin 3 to go high. Wait a second, so 1,000 milliseconds. Write pin 3 to go low, turn off the power, and then delay another 1,000 milliseconds. So wait with it high for a second, wait with it low for a second, and repeat. Okay? So that's the code, and that's kind of how you program an Arduino. We'll get into the actual code mode in a second, but I think that's a good one. Okay? So yeah, you can keep track of this. You can set these variables. Let's see. Dun, dun, dun. How do I want to do this? This is not really necessary now, is it? I probably added this line just for an example, but it's really just C++ code, more or less. So yeah, and you can do either one, but eventually, to do the coolest things, you got to do the C++ version. Okay, so there's that. Yeah, so the goal is let's make a fancier version. I'll show you that program where we push a button and we have like a light turn on. Okay, that'll be my next example. So that one should be, if I named it right, Arduino push button. Cool. So here is a fancier example. So I'm hooking up the Arduino like this, dun, 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 in an interesting way. Let me just show it to you first. If I press the button, the light turns on and stays on. And if I press the button again, the light turns off and stays off. Okay, so that's that. So let me show you what's going on there. So I'm hooking into a couple pieces of the Arduino. So I'm powering it still, like I'm getting 5 volts and ground and all that fun stuff. These rails have power. And then I'm also using digital pin 3 to power an LED, and then digital pin 7 to get input from this push button. So essentially, look at how it's taking power. It's taking power that's always on, and when I press this button, it's going to send power to pin 7. So pin 7 is going to be used as input. It'll be used as input rather than output this time. We're getting input from the user, so if I press the button, it's seeing power, and it's like, oh yeah, the user pressed the button. And if I don't press it, it's seeing like no power, 0. It's seeing ground. And then there's a reason that I have to do it this way. I can't just like send a plus to here, and then the circuit's open when it's not pressed. I have to find a way to complete that circuit. I have to bring in negative to here, to pin 7, and through a resistor, actually, a very high-powered 10 kilo ohm resistor, just so that it knows I'm not pressing anything right now. For weird electricity reasons, we have to ground the button itself through a giant resistor so that it sees 0, instead of like, it doesn't know the difference between on and off at that point. Like open circuit versus closed circuit, it gets very confused. So like when you're sending power, like it sees the 1. But when you have a closed circuit, like when you have an open circuit, there's no power going through, like the button isn't pressed, there's no power being transferred. It doesn't actually see a 0, it sees like some weird value that oscillates between 0 and 1. It can't really tell what's there because there's no actual power flowing. So just let a little bit of baby power flow from negative, and it will see that. See 0-ish volts. Okay? So that's the goal, and that's why we need that. So yeah, if you use a push button, you need that. So let's go to the actual code now. Whee! So here's the code blocks version again of what's happening here. So what we're doing is we're using pin 7 as input this time. So here's pin 7, we're hooking into that, that's input. If we press the button, it sees high voltage. If we don't press the button, it gets the low voltage still from the negative rail. So yeah, that's what's happening there. And so it's like if, this is an if block. If pin 7 is high, then set my isLightOn variable to like the opposite of what it was before. We'll get into that in just a second. And then wait 100 milliseconds. All right. So I'll explain this in a second. Let me just go through the code. And then if the light is on, like the light variable on is set to a 1, then we'll set pin 3 to high. Otherwise, we'll set pin 3 to low, and that will just like power this thing until the end of time. Okay, this LED being powered through pin 3 programmatically. All right. So here's kind of the goal. So, okay, we're going to use this isLightOn variable to keep track of whether our Arduino should be powering that LED. It will start out off, and then when I press the button, to give power, pin 7 sees power, what will happen is, okay, yeah, I see power. I see that the pin 7 has been taken high, so I am going to set the isLightOn variable to 1 minus whatever it was, the absolute value of that. Okay, that's what's going on. Set it to 1 minus the absolute value. So 1 minus isLightOn currently, and then the absolute value. So like 1 minus 0 is going to be 1. And so you see how that's going to oscillate it from 1 to 0. That's perfect. So that'll do that. And then if it's 1, you press it again. Like if it's high again, then we want to turn it off. So set isLightOn to 1 minus itself. So 1 minus that. Just like that. And I guess the absolute value isn't really necessary now, is it? But it'll set it back to 0. Cool. Isn't that nice? So that's what's going on. And then we waited 100 milliseconds because imagine that we didn't do that. And if I press this button, this loop is running a whole lot, right? 1,000,000 times a second otherwise. I have to tell it to slow down because otherwise, if I click this button, it would have hit this code 1,000,000 times. Potentially, yeah, that might be an actually accurate number. It might have hit that code 1,000,000 times because it was looping so fast. And so we were just like setting isLightOn to 1 and 0 1,000,000 times a second. And we're not actually sure what happens when we unpress the button. So by waiting, that's not going to mess with isLightOn for 100 milliseconds, give the user time to like take their hand off the button, and like it'll actually be set to a normal value. Okay, so that's why we wait. We're going to wait so that the user can like have time to unpress the button and we don't keep on like oscillating this value on and off, 1 to 0, 1 to 0. It'll actually be something concrete after that. And then after like we've taken our time to maybe set this variable or not, then we will like light up the thing or not light up the thing. Like this if statement, this first part is very fast, and then it's like it's just powering or not powering the LED from then on. Okay, so that's the goal. If I don't press it fast enough, I have to start the simulation. You gotta take your hand off fast enough, otherwise it's like gonna get very confused. Okay, so yeah, that's pretty cool. And then it just stays on. It stays on this if statement so fast that it's still 5 volts still by the time we get here. Okay, it keeps setting it to high. It doesn't change it until we see some other thing. All right. So yeah, that's that example. I hope that is interesting to you. But if you go and you look at the actual code, oops. No, I have to show the blocks plus text. The automatically generated code honestly it makes more sense to our computer science brains. So now we're actually using this variable isLightOn. We've got we've set up our pins. All right, so pin 7 is going to be used for input because we're sending power to pin 7, and that'll be from our button press. And then pin 3 will be used for output. We're gonna send power across pin 3 to an LED. All right. Oh gosh, come back. All right, and then here's our loop. What happens in our loop forever? If we see high along our pin 7, then I would like to mess with this. How can I make this whiter? Give me a second, we'll find it. I think I just need to drag the whole thing across. No, there has to be a way then. Come on. I legitimately can't see how to make this bigger. I'm so sorry. Like, you can't see it right now. Can I make this smaller? Like if I zoom out? I'll have to make the text size smaller. I'm very sorry about this. I'm very confused. There is a way. There is a way for me to show you this entire window, and I'm gonna show it to you. I really can't drag it out. That's so weird. All right, so I'll just do this, I guess. So yeah, isLightOn. If it's high, pin 7, change isLightOn to like 1 minus whatever it was. You technically don't need the absolute value, but like there's a block for that if you ever need it. And then wait 100 milliseconds delay so that like when you press, it's not being like this loop isn't running on and off, on and off. It's like you actually are gonna set isLight on. It's gonna stay like that for a little while. It gives you 100 milliseconds to take your hand off the button. And then from then onwards, like if that variable is 1, make sure that pin 3 is seeing high voltage. Otherwise, make sure it's seeing low voltage so that it's powering that LED in the state that we want it to be powered. Okay, so that's what's going on. Yeah, please yell at me if you have any questions about this stuff, but that's kind of what's going on. That's the example. All right. In addition to like digital GPIO pins, like digital ones, you can hook into cool things on these analog GPIO pins and do stuff like that. So these are analog inputs. We're not really I'm not gonna give you any examples of those, but just one actually. I'll give you one. But here's kind of what's going on there. An analog pin, like you can hook in a wire to that. Analog pin number 0, for example. And you can get input from that, and it's not always just like high or low, and it's not always 1 or 0, on or off. It's like things in between. So like you can imagine that like old analog electronics that were used in like recording studios were getting sound from voltages. That's kind of what's going on when you play guitar over an amp. So like you're seeing like oscillations between 5 volts and 0 volts and everything in between. So that's the kind of stuff you can read like partway between on and off with analog inputs. Okay, so that's like old school stuff, but we care mostly about 1s or 0s, on or off, in our digital electronics these days. All right, so yeah, let's do one last thing. Let's make an 8-bit binary counter. Let me show you that one. That's this one, and again you can hook in the Arduino to do it however you want, but let me go to this pre-made example because it takes a lot of dragging to make this work. But I've got a bunch of LEDs. I've got 8 LEDs, and what I'm going to do is I'm going to count up one every second. It's like a clock almost. And so like 1 0, now it's 2, then it's 1 1, it's going to be 3, right? And then it's going to be 1 0 0, so it's counting to 4, 1 0 1 5. So it's counting up in binary with lights to mean the 1s and the 0s. There's 7, now it's 8. Isn't that cute? Now it's 9, 10, and so it'll get all the way up to 255, and then it's going to have to wrap around. But that's a program you can write and have it like display a clock almost. So here's the actual code for this, and this I did not use blocks for. Okay, so yeah, this is more or less C and C++ kind of together. I'll show you that there's some methods that you can call later. But here's the setup. So I'm using pins 0 through 7, of course, and they will all be used for output. All right. So I'm just in a loop. You can do that. It's like, hey, all those pins you're going to be used for output, and then I have a counter that's being built up, and it's a char, unsigned char. So it is exactly 8 bits. That's perfect. And then what I'm going to do is, if you notice, it's pin 0 being set. That's like the highest bit, all the way to pin 7 setting the lowest order bit. So like as you extract bits, like whatever your count is, 0 0, let's say your count is this right now, it's like it's 5, and I want to figure out, hey, should I light up this LED or not? So we have to figure out, is this LED lit up? It's bit number of our char, it's bit number 0 1 2, bit number 2, and so that is going to be used, like we have to power 0 1 2 is bit number 2. Oh gosh, bit number 2 needs to be turned on and off by pin number 5. So I kind of did it backwards. So it's bit I needs to power pin 7 minus I. Okay, so that's the calculations that you'll see being done here. So yeah, here I am like checking and seeing if that particular bit was set. So I'll shift it right by 2 to get it in the lowest position. So that'll make this number, right? I'll make the 1, and then you can just AND it, whatever you see here, with 1, and if the answer is 1, that means it was on, because 1, that's a 1 only here and nowhere else, so that will see a 1 given back to us. Okay, that's the goal there at least, and let's move that over. Oh, not everything. Almost, there we go. Now it's less confusing. So yeah, we'll just shift right and AND with the number 1, because if there was a 1, it would be in that position by now, after the shift. Okay, so that's how you check if a bit is set. So yeah, here I am going through every bit of this counter variable, and I'm like, all right, for bit 0, starting with that, shift it right by 0 and with 1, and that should set pin 7 minus I because I kind of wired it backwards. Okay. If it's set, make it high, otherwise make it low. So for all those, like if it's bit number 2, like shift right by 2 and with 1, hey, was that still 1? If so, bit number 2 was high, so I want to set pin 5, essentially, because that's being set into bit number 2's LED. Okay, and I hope that makes sense. And so it's counting up every second because it's doing this, and then it's incrementing the counter, and then waiting for a second. And so everything stays as it was for exactly 1 second, and then you come back to the rest of the loop to do it for the new value of the counter. Isn't that fun? And apparently you can use little breakpoints here too, but to debug your code, but I think this is self-explanatory enough for us for now. So isn't that cute? That's a fun little example, I think. All right, and so you can power LEDs, you can make a little binary clock. Those used to be popular back in the day. So that's a good start to all these examples. Let's move on, because you can drag out cooler things and have them be powered by the Arduino. The Arduino knows how to do LCD displays. Like you can hook up an LCD to an Arduino. Here's like an example for how to do that, and have it say "Hello World." So you can hook one of these up to your virtual or real life Arduino if you ever get one. So you have to power it in a fancy way. You got to like there's different pieces to this Hello World thing. Let me show it to you virtually at least. So you can drag out. There's a couple pins to the LED it needs. It's got a cathode and anodes. It needs positive and negative, and then like you give it information through like these different pins through the Arduino's library, because it sends things in a digital way to it. All right. So the Hello World example, I followed this to get it hooked up, but like here's what you needed to do. You need to set this pin, put that on pin 12. This needs to go to pin 11. This needs to go to pin 5. All these things I needed to hook up in this exact way. Okay, and then you could use there's a library in the Arduino code, like liquidcrystal.h, because that's what LCD stands for, right? Liquid crystal display. And yeah, you just set it up and you give it this information and you can print to it. Like there's a library that's been written around this. So here it's going to say "Hello World" when we program it on, when we turn it on at least. That's the code that we loaded into it, and it's just going to keep saying the same thing. But you can update it, of course. I just kept it saying the same thing though. So yeah, I included this library, and then I hooked everything up like this website told me to, and yeah, then I can use this fancy stuff. So I'll initialize the LCD display as a global variable, because that's what the Arduino likes, and then I set it up to say that like this was an LCD display that's 16 columns by 2 rows, so that it knows how many things that it can print out at once. And then the idea is that you can like there's a concept of a cursor. All right, so that's like where you put your little cursor in Microsoft Word, or this thing where you can type here, right? So all that stuff, you start it at 0, 0, because that's where I want to start printing. So this is 0, 0, column 0, line 0, that's where I want the H to go. And then from there, from the cursor being there, go and print "Hello World." Does that make sense? That's kind of how that works. And then like move the cursor to column 4, 0, 1, 2, 3, 4, but line 1, there it goes. So that's where I want to print the next thing. Then print from there all this. That's what's going on. Okay, so that's why we see exactly this, and this is happening in a loop. So technically it's just like redisplaying the same thing over and over and over again. But you can change this, of course. Isn't that fun? So that's what I want you to try now. So given all this, like take my example. I've given you my link to my code, so you can even get this and go here. But I'd like you to try to make an animated star bounce from left to right on one of the rows. So like could be the first row, could be the second row, it doesn't matter. But you got all these pieces. They're like 16 technically, but like pretend that this is how many rows and columns you had. Kind of like start a star here, and then like move it here to the next one. Move it here to the next one. Like have it move to the right every second, and then make it like bounce off the wall and move back. Does that kind of make sense? That's what I want you to do. Okay, so you're gonna need to delay, like to keep the star shown somewhere. You got to delay and not do anything for a little while. So you have to use delay, in your loop. And then you also are going to need to clear out the display, because when you print more things, like it overwrites things that were there and keeps the old stuff. So if you want to clear out the display every time you're drawing the star in a new place, there's an lcd.clear method that you can call. So just like do that before you do anything, lcd.clear always. Okay, so give that a try with this. Here's some starter code essentially, and a starter Arduino. You can copy this and give that a try to make an animated star bounce from left to right. I think that's a fun little example for you. And so here's the answer. Here's how I got it working. So I kept all the wiring from the hello world, of course, and there it goes. I used the first column. Look at it bounce. Isn't that cute? Whee! Amazing. So yeah, here's the code for that. Here's what's going on. So yeah, set it up all the same, and then here's how I stored what I would like to keep track of. I've kept track of like my star. I called it a dot. My dot begins its life on column 0 of row 0, always row 0, and its direction is going to the right. So I want to like add 1 to it each time when it's moving to the right. So that's like a positive offset. And I'll make a -1. I'll use -1 if it's going to move to the left. All right. So in a loop, I'm going to clear my display, set my cursor at whatever column I'm thinking about right now of row 0, line 0, and then that's where I put my star. Does that make sense? And then I'm just delaying 100 milliseconds. So this is like, it's not simulating accurately right now. It's not perfect speed because it's like, I don't know, it has a lot of electrons to move around and think about. So it's not, it's going a little slow, is what I'm trying to say. And then move over the dot, move over the star to some other place. Like take it where it was, then move it by its direction. So like if it was 1, that means make it go to the right. If it was column 0, now it's in column 1. If it was in column 5, now it's in column 6. But if I hit one of the walls, I want to bounce off the edge. If my column is 0 right now, or it's 15, I would like to bounce off in the opposite direction. All right. If I just made it a different column and it's about to hit the wall, we're going to display it. But the next time we come around, our new direction is going to be negative. So like -1. Like if it was over here, -1, adding that to wherever we are, like column 15 is going to make it 14, 13, and that'll move it to the left now. Does that make sense? So that's a fun little example, I think, and I hope that is useful to you. So yeah, it would be fun to have these in real life for sure. So go buy one if you're interested. It's really fun to think about what you could do, all the possibilities. All right. So yeah, just have a bunch of little examples of this kind of stuff. It's like hardcore using Arduino to read fun information from like sensors and things. So like let's do that, for example. So here is actually an analog thing. We're gonna actually plug into the analog pin. There is a force sensor that you could buy in real life. These exist, right? They're in your phones, for example. And like when you shake your iPhone as you're typing, it'll be like, do you want to undo? And so we're going to use a force sensor and hook it into an Arduino. And if it sees enough force, we'll just be like, we'll print undo or something. Or we can imagine that like was used to actually undo our input. But a force sensor in an Arduino, or sorry, just in a circuit, what it is, it's a variable resistor. Don't ask me about how it's actually made deep down, but apparently if you shake it, the resistance changes. And so what we'll see is as we shake it, we'll see analog data. Like you shook it a little bit, it's going to produce, it's going to let more power through, for example. It's like we're going to get analog data, an amount of force. So you can do stuff if there was a little force, or if there was a lot of force. You'll see the difference. You'll be able to see the difference rather than just zeros or ones. So that's what analog data is good for. So where is that force sensor? So you can't actually shake your Tinkercad assignment. So here's a force sensor. Here's what it looks like. And we're going to give it power and then also hook it into the analog input, analog A0. Okay? And so here's let me just show it to you first. It's like not enough force. Here's how you shake this virtually. You just like tell it how many newtons it's going to have. Undo. And then it'll notice that like eventually it'll go back to reset itself. But like, oh, if there's enough force, it's like undo. Otherwise, we bring it back down, not enough force. That's like us shaking it. That's our example, okay? So, I'll keep that on. But here's what happens. All right, so again, actually, we have to hook it to negative, to ground as well, so that it sees not like that floating value thing. So it needs to see 0 if we're not shaking it enough. So that's like 5 volts in ground through a big resistor for that same reason we talked about before, but like output is eventually going into A0, okay? So what's happening is we're setting up the LCD display again, and then we're also reading from the analog input. We're saying analog read from A0, so that's where we hooked this thing into, and then I'm actually going to print on the serial monitor here how much force we see. How much force we see right now. And so every time I change it, it's running right now, it'll print how much force it sees. So it sees like a number, right? 0 all the way to 145, 197, 333, all those things. It's seeing numbers, and it's not very well calibrated, I guess. But you see how like the top end of the bar here is 914. That's the number it's seeing. So like we're adding, like we're giving it power or not power by shaking it, essentially, because that's going to change its resistance. Isn't that cool? So like that's what's going on, and so we'll just check and see, like that'll be like our force number, and we'll just like try it out and just be like, okay, maybe if we see 500, like that's enough shaking to mean like undo. Otherwise we'll print not enough force. Okay, that's the idea. So isn't that fun? I guess this cute little emoji is not really being printed. We can fix that. We can say we'll move our cursor. We'll say LCD set cursor to line, I don't know, line or column what, 13? Yeah, 14 of line 1. And then we'll print our silly emoji. There. Oh, what did I do wrong? Oh, I didn't paste it properly. Surely that was the problem. Yay, there's my silly emoji on the right now. It kind of looks dumb, but that's okay. That's okay. And then it'll get cleared, of course, when we say undo. Yay. So, yeah, that's kind of the example. We can read from these analog pins, and that will correspond to some number. And depending on the number that we see, we'll say that like that's enough shaking. It's pretty cool that you could make an actual real life thing that changes its resistance as you shake it. I think that's very interesting. And then we wait 100 milliseconds, 0.1 seconds, to try it all over again. Okay, so yeah, that's reading from sensors. That's a good example, I think. What else? I think I just want to show you one more cool example. I want to show you the difference between two kinds of motors, if you've not heard of the difference before. So there's two kinds of motors that you care about. There's a DC motor and a servo motor, and here's both of them. This is a DC motor, this is a servo motor, and if I turn them on, you can kind of see immediately what the difference is. I need to like give this power though. Take some amps, take some volts. Give it just a baby amount of stuff. Baby amount. It's hard to make it do any different. So it's very, very finicky, I guess. If I give it some voltage, it's going to start moving this thing, and it'll tell you how fast it's moving there. So it's just the DC motor spins really fast. All right, you can't really control it. Give it more power, it spins faster. This is a servo motor. Look at it go. It's not spinning very fast, but it's spinning precisely. That's the difference. There's some code to spin that motor. Whee. So here's, I don't know, some code that I stole from somebody on the internet, and I'm hooking into the Arduino and having it program this servo motor. It's like you can go exactly to this many degrees, like it knows how many degrees it's been turned. Isn't that cool? To however many degrees we got. Yeah, that's just super exciting. Okay, so yeah, it's just turning the servo to exactly 10 degrees, 12 degrees, stuff like that. So that's the main difference. Okay, so DC motors, they spin fast. You give it power, they spin fast. You're not really sure how fast you're spinning them. More power is faster though. Okay, so you can't really control where they end up if you send like a tiny amount of power. So they're for things that need to go fast, essentially. So like imagine you're making like an RC plane, something like that, or just even like the wheels of an RC car. Like those would have DC motors in them. Something like that, all right? Or just like an electric car. Just give it to the wheels. Like the propeller of an RC plane. Saws, just stuff that needs to spin fast. You don't really care about how fast. So that's what DC motors are good for. Servo motors spin real slow, but they're super precise. So you can tell exactly what degree you want it to move to, and it will go to exactly that degree amount, like we were doing in the code. Like spin to exactly 32 degrees relative to your like 0, 0. Maybe that's at 0, 0 at the start there. And so that's really good for like making robots, right? That need to grab stuff. 3D printers that need to like make something and have it be what you wanted it to be. Yeah, go to exactly this place on the print area. So yeah, that's the difference between those two different kinds of motors, and why you might want to use one over the other. Okay, so yeah, a lot of cool stuff about physical computing. Once we have an Arduino, we can do computation and have that like read the power, write the power essentially, which is very interesting. And I want to give you homework about that. So you got some time to do it, but here's going to be your homework. All right, so I want you to use Tinkercad to make like a counting device. So kind of like I was doing that count up device with the LEDs. I want you to do something similar, right? Something kind of similar to this one. You can sure start with this if you'd like, but I'd like you to make a counting device that's like similar to this, plus like the push button one. So like you'll look at both of these examples essentially. It's like the push button one plus the binary counter one, which it won't show me a picture of it. So remember the two. Here's what I want to see. I want to be here. So yeah, here are the things that I want you to do in Tinkercad. I got you. You need to drag out an Arduino for sure. You need 2 buttons because I want you to make a counting device. Like you press one button, it counts up. Another button, it counts down. And then I want you to have some sort of display. So like an LCD would be a good one. You could even use the LEDs if you'd like to use a binary counter. That's fine. Anything extra, like go for it. You can add whatever you want extra, but this is like the minimum requirements that I want to see. As long as you have the base functionality, I'll give you full credit. So I'll make it fun. All right. So here are the requirements for your counting device. So you're gonna like drag out 2 buttons, one for count up, one for count down, and you're gonna display a count. All right. The counter should start its life at 0 when you turn on your program, turn on your Arduino. It should be able to display in some way up to 99. So it should be able to show up to 99 if you count it up that high. And so pressing one button should make the counter count up. All right. And then it should be shown on the display after you count it. After you like change your variable inside your Arduino or whatever. And if you press the other button, that should make the counter count down, all right? And again, like it should be displayed. So you click it a few times, counts up to 3, click it back down to 1 or something, all right? So those are the only main requirements. You can choose what happens at the edge cases. So like, what happens when the counter is 0 and you press down? Do you want to be able to display negative numbers? Do you not? Add an if statement if so. So that's a thing. You can count by 2s if you really want to, and you also don't have to display the result in decimal. So you could make a binary counter with LEDs if you'd like, if that's more fun for you. But yeah, I just want to see a counting device with 2 buttons. Okay, so just follow my lead. Take these 2 examples, plus like a LCD example. I think like these are all public things you can look at. Some of those will be useful to you. All right. And so use that to make this work. And so what I want you to turn in, again, is I think it's a PDF, but or maybe it's just like a file upload. I forget. But one way or another, I would like a screenshot of your circuit that you made, your beautiful thing. I'd like a copy of the code that you wrote, all right? And then either I'd like to see, like, you can send a link, or like post a link in a PDF to a video where you just like you show off everything that you've done, or you can give a demonstration to me before the due date, all right, and come to office hours or something. So yeah, those are the things that I want to see, and those are your requirements for your homework 4. So yeah, good luck with that. Let me know if you have any questions. I'd be happy to help. And I think that's all for the day. So I'll see you in the next one.